Okay, let's begin. Let's begin. Today I want to, again, looks familiar, yeah? Looks familiar? Mike? That way? Okay, looks familiar? Taking that same challenge question that I introduced to you many weeks ago, I'm going to try to derive another relationship which allows us to tackle triangles that we normally couldn't do using Cosine Law and Sine Law. And what I'm going to introduce you to, what I'm going to ask you to sort of compare the two triangles with is using something you've already known from a long time ago. It is Pythagorean Theorem. Okay? So, the next question, next what if question that might come across is not what if we use cosine, it's what if we use Pythagorean Theorem to relate the two triangles together? Right? And remember, we're trying to focus on the height. We're trying to find the height here, so bear with me. I purposely did A, B, C in this particular case because it's going to help us derive this. Okay? And I purposely labeled this length to be x, which means that length is inevitably going to be b minus the x. With me so far?
Yeah.
Okay.
Yes.
Before I begin, I also need you to recognize something. Out of this equation, which part looks familiar to you? Yep. Which one? From here to here, do you see its Pythagorean theorem? Alright. Long story short, the cosine law is Pythagorean theorem, but next level. It's the Pythagorean theorem plus a little extra bit. Because after all, what kind of triangle do you use Pythagorean theorem with? Right angles. This is not a right angle. So we need a little extra adjustment to the Pythagorean theorem. With me?
If we put b in front, so like b squared equals, then would we do c minus a, or would we keep it c plus a?
We'll see.
Okay.
Okay, let's see. First, I'm going to use Pythagorean theorem to try to link this right angle triangle with that right angle triangle. So let's start with the easy one. This is my hypotenuse, which means a squared is going to be equal to base squared times height squared. With me so far? Great. Remember, Pythagorean theorem is c squared is equal to a squared plus b squared. In this particular case, that's my hypotenuse. Yes? So a squared is the height squared plus the x value squared. Did I lose anybody?
No.
Okay. Let's do this side now. This time the hypotenuse is the letter c. So c squared is equal to
b
height squared
minus x.
plus, this is a slightly ugly one. That's okay. Now, I'm going to rearrange it so that both of these will have the height as the common side. So we have a squared minus x squared is equal to height squared. Everyone see how we got that?
Yeah.
So far so good? Okay. And that is c squared minus this funky looking thing equals height squared.
Now you can do like the c squared minus bx.
Yeah. So just like before, sorry my dotted line is not quite the same.
How did
These two together, we are going to make c squared minus b minus x squared equal to a squared minus x squared. Now that is not pretty. So how about we simplify? I'm gonna guess simplify. Eric, you better put that away.
It would be x.
Some of the things that you can automatically see. There's an x squared here. And there's gonna be an x squared somewhere here. So automatically I'm thinking, okay, there must be a way to make this look nicer. I do not want to use this as a law, as complex. It's way too complex. Yes?
How do you know that they equal each other?
Because they are both equaling height squared.
Oh.
Right? So just substitution just like before. Okay? Let's open this up. Okay, so FOIL, expanding, distributive property. Okay? Minus, oh geez. This is b times b times negative x, and then negative x times b, so it's negative bx And then negative x times negative x, that's positive x squared. Did I jump too far?
Slow
It's
down.
okay.
Explain it kind of slow. No, you don't get to raise it. Yeah. Well,
b minus x squared is the same as b minus x times b minus x, which is b times b times negative x times b, and negative x times negative x, which is b squared minus bx plus x squared. And so we have these two grouped together, group-like terms, like that. And of course, there's a negative, so I'm just going to simplify this out. C squared minus bx plus 2bx minus x squared equals a squared minus a squared. Do we have enough to group like terms together?
Wait, when can you just drop the brackets?
When can I?
Yeah.
Well, when I multiply the negative one in, right, is there anything else that I need to separate from this?
No.
Brackets are only there just to keep two numbers apart from each other. When there's nothing else to keep them apart, you don't need the brackets. Yes? That's exactly what it means.
Bring the x squared over.
Yeah, so I add x squared to one side, I add x squared to the other side, all of a sudden what? These two will become 0, and all that's left is c squared minus b squared plus 2bx equals a squared. That's it. Looks a lot cleaner, doesn't it? But it's still not nice. What's not so nice about it?
2bx.
The 2bx looks a little funny. In fact, I don't want the x there because, well, it's some random number that I don't even know, right? If this was a question in a test, they might give you side length, but they don't give you little pieces like that. It's never going to be the case. So, what can we do about it? This is where the cosine comes in. This is a little bit of the creative side. So, please be a little bit open-minded. This is my angle, angle C. Adjacent over hypotenuse. Wouldn't you say that cosine of the angle C is equal to adjacent over hypotenuse? Which means x is a multiplied by cosine C.
Why can't we do opposite?
I could, but the whole point, I'm trying to make it easier on myself. This is where someone's like, hey, wait a minute. I want to involve the x because that's what I want to get rid of. Okay, so take a look. This x, every time I see x, I'm going to substitute in. What does that turn into? C squared minus b squared plus 2b a cosine c equals a squared. This part right here.
Oh my god.
That was my x. And so it still doesn't look nice. Can I rearrange this so that it looks cleaner? It looks like something I'm used to. Can I rearrange it to make it look like the Pythagorean Theorem? Let's get c all alone. If I get c all alone, just like the Pythagorean Theorem, it would be a squared
Plus b squared.
plus b squared
Plus 2b. Minus.
minus 2ba, but
And
b
cosine
times
C.
b times a is the same as a times b
And cosine c.
cosine c. And what's magical about, not magical, what's awesome about this relationship is this side and this angle are matching angle side pairs. You see it? The same letter. Number two, these two sides and those two sides, they are repeating. So if this was a 1, that becomes a 1. If this was a 2, that becomes a 2. So you don't have to like memorize anything. Here's how I like to memorize it, just like the sheet I gave you. This is the side angle match. The insides are the ones that I give you. Okay? That's a terrible way to actually distinguish. But I do a cleaner job on the sheets I gave you. Okay, take a look. Okay? The two ends, the side squared and the cosine of the angle, they have to be the matching side angle here. And whatever else is left over are the ones that go in between. The rest is learning how to use it. Okay?